Now let's look at this problem about changing the basis of a vector. Okay, so here let's draw the situation. We have our xy axis with the usual basis x hat and y hat. And now we have the vector v equals 1, 0 in the xy basis. Yeah. So this vector is actually this vector over here, the same as x hat. Yeah. This is our vector. But now we are asked to expand this vector in the basis e1, e2, where e1 and e2 are given by these vectors over here. So e1 is this vector. This is e1. And e2 is the vector minus 1, 1, which looks, let me remove this, which looks like this. This is e2. Okay? So the problem asks us to expand vector v in the basis e1 and e2. So how do we do it? So of course in the video you saw that we can do it, right? So you saw that any vector could be expanded in any basis. But how do I find the coefficients of the vector on that basis? So let's think about the problem. So the problem is that we want to write vector v, instead of writing it as vx times x hat plus vy times y hat, where vx is equal to 1 and vy is equal to 0, yeah, that's what this is telling us. So instead of doing it like that, we want to do it in another basis. We want to write the same vector v, so it's always the same vector. We want to write it as v1 times vector e1 plus v2 times vector e2. Okay, and therefore these two numbers, these two coefficients, will be the coefficients of vector v in the basis. So we could write v as this new vector v1, v2 in the basis of e1 and e2. So in this basis we could write those two numbers v1 and v2 as the coefficients. So how do we know what those coefficients are? Okay, well, the key is to look at this equation. So if we write this equation explicitly, this is just a system of equations, because v is a two-dimensional vector. So let's do it. So v is our vector, which is 1, 0 in the xy basis, equals v1 times a vector e1, which is 1, 1, plus v2 times vector e2, which is the vector given in the problem as minus 1, 1. Yeah. So there you have it. Those are two equations with two unknowns. So let's write the two equations explicitly. So the two equations are 1 equals 1 times v1 minus 1 times v2, and 0 equals 1 times v1 plus 1 times v2. So if we call these equations 1 and equation 2, now we can very easily solve them. For example, if we do equation 1 plus equation 2, we get that 1 equals 2v1, and therefore v1 equals 1/2. And if we substitute this into equation, for example, 2, yeah, so in equation 2 we have that 0 equals v1, which is 1/2, plus v2. So therefore v2 equals minus 1/2. And that's it. So in this way we have found the two coefficients of v in the basis e1, e2. Therefore we could say that v is equal to 1/2 minus 1/2 in the basis e1, e2. Yeah. So that's it. That's how we could do it. We could also check geometrically how this is possible. So we have to add 1/2 of e1 So we would reach this point, the midpoint, yeah, 1/2 of E1, and then minus 1/2 of E2. So E2 is in this direction, so minus 1/2 of E2 would be this. So when we add those two orange arrows, we end up with the green vector V, which was what we wanted. So geometrically, you can check it. So that solves the problem. That's how we expand a vector in a basis. Basically, we have to solve a system of equations. Okay, thank you.